Advanced EC2 features. Hey everyone, Ben Finkel here, and in this nugget, we're going to take a look at some various advanced EC2 features that are available to you when you're spinning up a machine. That's going to include something called machine type, which determines the size of your machine, the metadata and user data on that machine, which is descriptive data about the instance itself, and lastly, the various pricing models that are available to you when you want to buy EC2 instances. There are a lot of different advanced configuration options, choices, features that you can set up when you build out an EC2 instance. There's storage, networking, security. What I want to talk about in this nugget, though, is a couple of EC2 specific things. We'll cover a lot of those in other nuggets. EC2 specific things that you're going to run into when you first spin up and you first try out spinning up an EC2 instance. And the very first one that you're going to run into is something called machine type. Machine type is the answer to the question, how big of a machine do I need? So do I need a medium-sized machine, a little machine, a really large machine? If you think about spinning up your own virtual machine on your own hypervisor and your own host, well, typically you get to choose things like the number of CPUs that it's going to have available to it, how much memory that machine will have, and you'll get to choose a very fine-grained granular control for each of those options. Well, when you spin up an EC2 instance, you don't get to choose those things specifically. Instead, what you do is you choose from a preset list of machine types, and each type defines the core count, the amount of memory, the network performance, and the root volume configuration, either EBS backed or instance backed. And there's a lot of different machine types. You get a fair amount of granularity, a fair amount of control, but you don't get to choose the specific number of CPUs and the specific amount of RAM. You have to choose from these pre-built list of machine types. And they're all available in the documentation, or actually if you go right to the dashboard and spin up a machine, let's go ahead and do that. If we come here to the management console and simply select an image, you'll see the very next thing I get to do is choose a machine type from all this list of machines. And you'll see right here it defines the number of virtual CPUs, the amount of memory, the instance storage type, whether it's EBS optimized or not, the network performance. So there's a whole specific list, but it's a very large list. There are a lot of different options for me to choose from. Those options are there because the machine types vary in specialty. They all had a different letter associated with them. And the different specialties are general purpose, which are called the M series machines. Those are, well, general purpose machines. They're great for anything at all. Compute optimized, the C series. Memory optimized, the R series. Storage optimized, those are both D and I series. The D being optimized for large storage capacity and the I being optimized for large amounts of I/O. The GPU instances, the G series, and what are called the micro instances, the T series. If that seems like a lot of different options, it is. It might help to take a look at which machines types are going to work for your specific workloads. So we've got here some use cases. General purpose machines, the micro and the M3s and M4s, those are good for websites and web applications or even small databases. Your compute optimized are good for high performance fleets for doing things like, I don't know, video encoding. CBT Nuggets, for example, every time we upload a new nugget to our system, it gets encoded into the format that it's delivered to you and that you're ultimately watching this in. So we use compute-optimized instances in order to perform that encoding because they are high CPU, and that's what a very high CPU task would be, is video encoding. Memory-optimized instances, on the other hand, are good for high random access memory. Think about a distributed memory cache like Redis would be really good on those R instances. Storage optimized, of course, for data warehousing, large databases, data processing applications. GPU instances are great for 3D application streaming or even machine learning. Now, one thing to keep in mind when you're choosing from among all these instances is that you need to sometimes design for distribution. So I know the first time I learned about all this, I was like, oh, awesome, I can spin up a bunch of really little tiny micro or general purpose machines to host my application. And they'll be cheap, they're inexpensive the smaller they are, but I'll be able to handle a whole bunch of workload because I'll be able to distribute it and balance it across all those machines. But the design here is really important. Your application, your implementation has to be designed to deal with the complexities of a distributed environment like that. So think about a user workflow. What do you do when a user gets shuttled from one instance to another in the middle of their session? You need to make sure that any important data persists between those two instances. So using something like shared memory cache, for instance, you got to build those things into your application, into your implementation, and ensure that you've actually designed for that particular use case. Also, it's important to understand the definition of wide and shallow versus narrow and deep. Or you can think of this as total cost of ownership. Just because you can make a bunch of little cheap machines to handle your workload doesn't mean that that's the right way to do it. It may very well be the case that a few very large specialized machines are actually a better way to deal with your workload. Ultimately, knowing which is the best is going to change from implementation to implementation, and you need to do the research and do the work to understand for your implementation what the total cost of ownership will be based on these different machine types and what makes the most sense for you as an organization. Another really neat EC2 feature is instance metadata and user data. Metadata and user data are a series of in-memory key value pairs that are accessible from inside of your instance. They perform two very similar tasks. Instance metadata is filled in by Amazon when you spin up your instance, when you launch it, and it's data about your instance. It can change if Amazon changes it, but you certainly don't have the ability to change it. But you can always look it up, and you can write scripts inside your instance that execute, look up that data, and perform different things about that. That's opposed to instance user data, which you pass in yourself. That comes from you, and you pass that in at launch. Then it's immutable. Once it's been launched, that can no longer change, but at launch you can pass in that instance user data, and you can use it specifically. The best thing to do, I think, is to run startup scripts with it. But you can pump your own data in there to indicate things about your instance that you want to know while your instance is running. It's very easy to get instance metadata. When you're inside the instance, you're simply going to hit this URL right here, 169.254, 169.254, whack latest, whack metadata. And that's going to return something that looks like this over here. Each one of these items here is a key that you can look up and you can read from. And by the way, if you're not familiar with curl and the Linux commands, you can simply put this URL into a web browser in Windows, and you'll get the same thing listed back inside of your web browser. Then once you want to know the value for one of these keys, you simply stick that key on the end of the URL like I've done here to look up the AMI ID, and you'll get this data back here that'll indicate what Amazon Machine Image ID was used in order to launch this instance. User data, like I mentioned briefly earlier, is really cool. You specify it when you're launching the instance, and from there on out it's immutable. It cannot be changed unless you stop the machine, you move it into a stop state, then you can change it and relaunch the machine at that point. User data can either be a Linux script or a Windows batch script, and it'll run once per instance when it starts up. So if you stop the machine and you change your user data and start it back up, it's going to re-execute again. It's going to rerun. And if you get the user data, which is stored right here, just like the metadata, it's in 169.254, 169.254 latest user data, you're going to get back whatever it is. And this is just a couple examples of scripts that you might find. This would be a Linux script over here, of course, because this is Bash, and this is PowerShell over here. Notice it's in between these PowerShell XML tags. But otherwise, that's just straight PowerShell. And both of these scripts, simply install a web server, configure it, and get it started up so that you could have a web server spun up when your instance starts, as an example of how you might use a startup script inside of user data. Just an important note, both of these data, instance data and user data, are only available from inside the instance. So you can't look them up from anywhere that's not inside the instance. Another important point is that they are not secure. Any user that has access to the instance can look them up. It's not secured, it's not encrypted, so you really do not want to store sensitive data inside of either metadata or user data. Finally, I just want to take a minute to look at a few of the different EC2 pricing models. So initially when we talked about EC2, when we introduced it, we talked about pay-as-you-go. And that's, to me, the typical way, the on-demand pay-as-you-go manner in which you're going to spin up an instance, pay for it while you're using it, and then stop paying for it when you shut it down, when you put it into a stopped or terminated state. And the nice thing about on-demand pay-as-you-go is that it's fast and it's easy. You don't have to have any idea about how much capacity you need in advance. If you suddenly have a burst of activity and you got to spin up more instances, no problem. You're just paying for them as you use them. Once you're done using them, shut them down and you stop paying for them. That's really nice. But you can get cheaper if you do something like a reserved payment system. So you can actually reserve instance hours and get a much cheaper rate on your instance hours than on demand. But you are locked in for the long term. It's anywhere from 1 to 3 years. And when you use reserved instances, essentially every time you spin up an instance, you've bought those hours already, it spins down from those reserved hours. So you buy a bank of hours, and then your instances dig away from that. What's really great about that, if you know that you've got a lot of activity and you're really going to be using the system, you can get that cheaper rate, you can lock that term in for a long time, and if you happen to go over your reserved amount, say you didn't buy enough, you don't have to worry. You'll just start paying the pay-as-you-go on-demand price at that point. Another interesting way to save some money is to use scheduled instances. And scheduled is good for known burst periods. Think about Black Friday in a retail operation. You know that weekend, Black Friday in the United States, is a big retail weekend. If you've got a retail website, you can schedule some instances for that time, get a cheaper rate because you're paying for them ahead of time, and then spin them up, and you will have that capacity to handle that workload at a lower rate than if you reserved or chose on demand. Spot instances are a really neat AWS feature that I'm not aware of any other cloud offering. And spot instances basically allow other AWS users to sell back reserved and scheduled instances that they've already paid for to recoup some money. So if they've reserved a whole bunch of hours and they're not going to use them, they want to save some money, they'll sell them on this open marketplace. You set the amount that you want to pay for an instance, and when the price gets down or when somebody posts some hours at that price, your machines will automatically spin up, you'll pay for that, and you will get to do your workload. So that's really good for periodic work, occasional work with no known deadline, because you don't know when it might actually execute, or even if it'll execute. Maybe no one will go as low as your price, your offer. It's good for work that isn't all that critical, all that important, but once you hit that nice low price that you wanted to pay, suddenly you'll spin up, create those instances, and do your work, provide your workload. And then the final option is the dedicated host. This allows you to spin up physical hosts with your own per socket, per core VM software that helps you reduce cost, at least on the licensing side of things, but it gives you full flexibility over your environment. You control everything about that implementation, that hypervisor, etc. So that's more costly from Amazon's perspective. You got to pay a lot to get a dedicated host out of their data center, but it gives you the full flexibility that you might need in a really large enterprise organization for your implementation. So that concludes this nugget on advanced EC2 features. We were a little bit all over the map here as I just tried to collect some different features that you might find interesting into one nugget. But we talked about machine types, how you can size your machine appropriately given the workload that you need to run on that machine. We looked at metadata and user data, ways that you can get information out of your machine from the metadata or supply startup scripts, custom user data inside of that metadata. And we talked about pricing models, the different ways that you can pay for an EC2 instance when you buy them. I hope this has been informative for you, and I'd like to thank you for viewing.